Chapter 4, Section 3 is called Patterns and Nonlinear Functions. By the end of this, there's two parts. You should be able to model these functions using graphs, tables, and equations. Alright, this table shows the relationship between the number of steps in the staircase below and the number of blocks needed to build these staircases. Copy and complete the table. Is the relationship a function? If so, is it a linear function? Okay, remember that in a function, we have 1x for every y. Okay, you can have a function without having a linear function, and that's what we're going to talk about today. But the first thing I'm going to do is have you look to find out how this table is changing. So for one step, it only took one block. For 2 steps, it took 3 blocks. For 3 steps, it took 6 blocks. So we need to figure out the pattern so that we can see what 4 steps would be and what 5 steps would be. Alright, so if I look at how each one of these is changing, all of these are changing by 1 because we're adding 1 step to each picture. The number of blocks that it takes, however, to get from 1 to 3 was 2 steps, or 2 blocks. From 3 to 6 was 3 blocks. Okay, now if we added a 4th step, we'd be adding on 4 blocks, which means that this would be a 10. And if we have a 5th step, we'd be adding 5 more blocks, so this would be up to 15. Okay, so our ordered pairs would be 1, 1, 2, 3, 3, 6, 4, 10, and 5, 15. Okay, so I only have one y value for every x value, so yes, it is a function, but because it's not changing by the same amount every time, this is not a linear function. Yes, function, non-linear. Okay, and those nonlinear functions are what this section is going to talk most about. Vocab word for today is nonlinear function, which is a graph that is not a line or part of a line. Remember from a couple lessons ago that function is for every x, there's only one y. Alright, here are some examples of linear and nonlinear functions. A linear function is a function whose graph is a non-vertical line or part of a non-vertical line. So see how all of them are straight lines, but they're not vertical? Those are linear functions. Nonlinear functions are functions whose graph is not a line or part of a line. So these are curved lines. This one, and this one are all nonlinear functions. Alright, problem 1. The area in square inches of a pizza is a function of its radius in inches. The cost in dollars for the sauce for a pizza is a function of the weight in ounces of sauce used. Okay, graph them and tell if they're linear or nonlinear. Alright, so we're going to split them up. First, we're going to start with the pizza area. And we're going to do the same thing. First, let's see if it is a function. Okay, these appear to be going up by 2s every time. And these don't look like they're changing by the same amount. To get from 12.57 to 50.27, we're adding 37.7. Then to get from 50.27 to 113.1, we added 62.83. Okay, so we already know it's not changing by the same amount. The next one, we have to add 87.96. And then 113.1. Okay, so we know that it is non-linear. Okay, this says how can we tell by looking at the table if it will be linear or non-linear? We can tell by looking for a constant change. Because we don't have that constant change, it's going to be non-linear. Alright, then they want us to graph it. If we graph this, we'll be able to count by 2s on the bottom. and the graph is actually going to look something like this. All right, now we'll go to the sauce cost. This one also adding 2 every time. And on this side, much more friendly. It looks like we're adding 80 cents each time. So because this does have a constant change, it's 80 cents for every 2 ounces. That means this one is going to make a straight line. This will be linear. It would look something like this. Perfect. So reminder, linear means it has the same constant change in both the x's and y's. Nonlinear means that it doesn't. All right, one more example before I let you work on the part 1 questions. The number of centimeters is a function of the number of inches as shown in the table. Is the function linear or nonlinear? Okay, on the x side, it looks like we're adding 1 every time. On the y's, it appears to be adding 2.54 every time. Okay, so that means that for every 1 inch, it's another 2.54 centimeters, and it's changing by the same amount every time. So this one will be linear. All right, in your book,